Hello everyone, welcome to the 11th tutorial class on artificial intelligence. In this class, we shall discuss uh, basic operation of fuzzy system, that is fuzzy logic controller. After that, we shall also discuss about the fuzzified output. That means what will be the output corresponding to a fuzzy system, and followed by defuzzification process, which convert a fuzzified output into the crisp value. And we shall discuss two very popular method for the defuzzification, that is CoG and CoS method, that will be discussed in the upcoming slides. Now coming to the fuzzy logic controller. This figure denotes the generic structure of a fuzzy logic controller, or you can say it as FLC. Basically, fuzzy logic controller are special type of expert system which employ some kind of knowledge, and this knowledge are expressed in terms of some kind of fuzzy inference rule, and we need also a inference engine or fuzzy inference engine to solve a particular problem of real life. Okay, so fuzzy logic controller are very useful where exact mathematical formulation is not feasible. In that scenario, we can use a fuzzy system. You can see that these are the different module for the fuzzy logic controller or fuzzy system. Here, first of all, we need some kind of input, and input should be in crisp value. That means that is in real life valued. Okay, and this value is applied into a fuzzifier that convert this crisp value into fuzzified value in term of membership function. Okay, and here you can see that there are fuzzy rule base. Here different type of rule are already stored. Okay, based on which we can take different decision. Okay, so fuzzified measurement are used by the inference engine to evaluate control rule stored in the fuzzified rule base. Okay, and the result of this evaluation is also a fuzzy set, and this can be done by inference mechanism. Different kind of operator that are already discussed in earlier classes that are implemented in the inference mechanism. Okay, so fuzzified input goes to the inference mechanism system, where fuzzified uh, by using fuzzy base rule or fuzzy inference system, we get some kind of fuzzified output. But in real life, whenever we want to use the output, that output should be in the crisp value. So we need another module that is known as the defuzzifier. So the function of the defuzzifier is to convert the fuzzified output into a crisp value so that we can use it in real life scenario. Okay, so defuzzification is the final step, and the defuzzified values represent action to be taken by the fuzzy controller. In this class, we mainly focus on the defuzzification process. Okay, now defuzzification. So we already told that defuzzification means to convert the fuzzy value into crisp value. Now consider a linguistic fuzzy rule where it has been mentioned that if T high or temperature is high, then rotate fast. Okay, so T high is expressed in term of fuzzy. So the corresponding output should be in crisp value so that we can use it in the real life system. So we need to convert it into the crisp value. Now consider the second case. We already known that fuzzy inference rule. Okay, so consider this R1 rule and R2 rule, where it has mentioned that if X is A, then Y is C, and if X is B, then Y is D. Okay, where a, b, c, d are different membership function, and x is the input and y is the corresponding output. Now from this rule, what will be the corresponding crisp value that can be inferred from these two rules? Okay, you can see that this one is the a, this one is the b for the a membership function, for the b membership function. Okay, now if x has the value of x dash, so what will be the corresponding value of y? Okay, so how can we infer that? So to infer this, we need to use define defuzzification process. So that is the main agenda of this class. Now, whenever coming to the output of a fuzzy system, the output of a fuzzy system can be a single fuzzy set or union of two or more fuzzy set. You can see that there are n number of rules has been used here. Like if x is a1, then y is b1. If x is a2, then y is b2, like this. So for n number of rule, it has been mentioned that if x is an and y is bn. So all this rule can be explained in term of fuzzy relation also by using matrix format. But we mention it in term of linguistic way to understand with better clarity. Okay. So R1, R2, Rn all are the rules. Okay. Now the output of this fuzzy system will be the union of this output membership function like b1, b2, bn. So for particular input, like for x equal to x1, it is possible that b will be b union b2 union b3 union up to bn. That is the main concept of the fuzzy system or output of a fuzzy system. Now coming to the defuzzification process. Uh, there are different number of defuzzification process like lambda cut method, weighted average method, maxima method, centroid method, etc. Among these four types of uh, defuzzification process, centroid method is most popular, and it has better accuracy and efficiency also. So in this class, we will basically discuss two types of centroid methods. First of all is center of gravity method or COG, and second one is the center of sum method, that is COS. Okay, so basically we will focus only these two type of defuzzification process for for our particular FLC or fuzzy logic controller system. Now coming to the COG method. The basic principle in the COG method is to find out the point x dash where vertical line would slice the aggregate into two equal masses. Okay, here you can see that this is the membership graph with respect to x and mu. So we need to find out this type of point that denote the center of gravity. Okay, so mathematically COG can be expressed, and this center of gravity basically denote the defuzzified output or crisp value. So x star or x dash will be nothing but integration of x mu c x into dx divided by integration of mu c x dx. Okay, so graphically it can be expressed in term of like this. Okay, so uh, for the COG method, we need to mention few important points like x star is the x coordinate of the center of gravity. You need to understand that x star is basically the x coordinate, that means distance from the origin to this, that is nothing but the that is x star. Okay, so x star is the x coordinate of the center of gravity, and integration of mu c dx basically denotes the area of the region bounded by the curve mu c. That is the property of the integration, that is nothing new. So if mu c is defined with a discrete membership, okay, consider the another case where the mu c is not continuous but it is expressed in terms of some kind of discrete value. So in that scenario, mu c will be COG can be expressed in terms of the integration, or sorry, summation. Basically integration is nothing but summation. So for the discrete case of membership function, x star will be summation from I to I equal to 1 to n xi into mu c xi divided by summation from I equal to 1 to n mu c xi. Okay, So that is the particular case where the membership function is discrete type. But whenever membership function is continuous like this type of graph, and we need to use this kind of uh, function, integration x mu c x divided by integration mu c x dx. Okay, and here it is worth to mention that x is the sample element and n represent the number of sample in fuzzy set C. Okay. Now coming to a real life example, consider these two membership function like mu c1 and mu c2, sorry, c1 and c2 for the linguistic variable, and mu c1 corresponding the membership function is mu c1 and mu c2, mu c2. Okay, now define another fuzzy set C, that is the C union of c1 and c2, and if we make union of this c1 and c2, that will be nothing but the maximum value uh, of between c1 and c2 in this region of x. So this graph denote the basically sorry, union of c1 and c2. Okay, so this is basically the fuzzified output. If you see, this one is the input c1 and c2, this one will be the fuzzified output, and it is expressed in term of c1 union c2. Now we need to find out, we need to find whenever we want to apply COG process for this kind of membership graph or fuzzified output graph, so we need to divide it into uh, different area. Okay, so here you can see that for this kind of graph we have divided into 5 number of area like a1, a2, a3, a4, and a5. Okay, now for each case, why need to use this kind of uh, s- div- uh, differentiation or divide for particular, for consider this a area like this one, this curve. So particular this area, the corresponding membership function has the defined value. For a2 this is constant, for a3 this has been increasing, for a5 again this is constant, for a5 this has been decreasing. So for each of the uh, case, for each of the area we need to identify the corresponding membership function. So here by using this simple process we have calculated corresponding membership function like from 0 to in between 0 to 2 the corresponding value 0.35x, 0.35x, from 2 to 2.7 the value is constant, that is mentioned by zero point 0.7. Okay, and next one is x minus 2, next one is the 1, and in between 4 and 6 it will be zero point 0.5 x plus 3 like this. Okay, so using the simple quadratic equation or linear equation we can calculate this corresponding membership function. So we need to identify all the membership function for all the areas. Okay, now just apply the integration process for this all the 5 areas. So the corresponding crisp value will be integration x mu c x dx, that is defined by n numerator, and denominator is defined by the integration mu c x dx. So here you can see that the value of n, if we make the integration, the corresponding value is 10.98 and the value of the denominator is 3.445, and if we divide them the corresponding value of x star will be 10.98 divided by 3.445, that is 3.187. So this x star denote basically the uh, defuzzified output or crisp value, output crisp value. You can see that this is a decimal number 3.187, so obviously it is a crisp value. This is not the membership function that exists in between 0 and 1. Okay, so by using this kind of process which is called as COG, we need to divide the whole the membership graph of the output in the different area, and we need to identify the membership function for all those area. Next we just use the corresponding formula to identify the crisp value, that is integration x mu c x dx divided by integration mu c x dx. Now coming to the second method, that is also very popular, which is known as the CoS method, that is center of sum method. Okay, so here again the process is similar, but here instead of finding the center of gravity we need to identify the corresponding value of centroid or geometric center of the area. Okay, So if we consider this kind of three inputs like C1, C2, and C3, and so and X1, X2, X3 are the different inputs. So for this particular rule, particular cases, the corresponding output fuzzy set that can be given by like C equal to C1 union C2 union Cn. Okay, so for this particular case, the crisp value of the output by using CoS method is defined by this particular formula x star, that equal to summation from I equal to 1 to n xi multiplied by aci divided by summation I equal to n to y equal to 1 to n aci. Here aci denotes the area of the region bounded by the fuzzy set. Okay, and the ci and xi is the generic center of the area aci. So here you can see that if there is for for the this particular membership function, a1 is the area and the x1 denote the generic center. Okay, that means basically the middle point of this particular region. Okay, geometric center xi is the geometric center of the area aci. Obviously uh, this x lie in the x axis. Okay, so this one is the second area, this one is the third area. Okay, now after getting this all the values, just substitute them in this equation, we get the corresponding defuzzified output values. Okay, it is interesting to note that in COG method the overlapping area is centered is counted once. Okay, whereas in COS the overlapping is counted twice or so. Okay, and another thing, in COS we use the term the center of area. Okay, so we use the term COS instead of center of gravity or COG. Now let's consider the example that will help you to understand the COS method with more clarity. So yeah, here you can see that there are three different kind of membership function for so mu c1, mu c2, and mu c3 for different variable. Sorry. Okay, and for the and x define the inputs. Okay, so these three functions. So for three cases, for these cases, first of all, what you need to do for the first cases, we need to calculate the area. Okay, we need to identify the area for the mu c1. So for ac1 will be half into 0.3 into 3 plus 5, that is the area rule for the trapezoid. This one is the trapezoid membership function. Then by using this formula you can get the corresponding value of the trapezoid. Okay, up into 0.3 into 3 plus 5, and the value of the geometric center will be 2.5, as the x is extend from 0 to 5, so the center will be at 2.5. Similarly for AC2 we calculate the corresponding area and find out the geometric center, and for AC3 similarly for the third membership function we also find out the corresponding area and the geometric center. Now substituting all the value of AC1, X1, AC2, X2, and AC3, X3, we can get easily X star, that is the defuzzified output or crisp value, by using CoS method. So just substitute them in this equation. X star equal to summation I from I equal to 1, no, sorry, I equal to 1 to n xi aci divided by summation of from I equal to 1 to n ACI. So by using this formula and just substitute them, then we ultimately get the crisp value, that is 5.00. So okay, so note that uh, for the same cases, if we can consider the um, COG method for the same defuzzified output, sorry, same fuzzified output, that is C1 union C2 union C3. So we can use the by if we use the COG method, we can get the value 4.9. So by using COS, we get the value uh, 5, whereas in using COG method, we get the value 4.9. So which are very, there is less difference between these two methods. So we can use any of the defuzzification process, either COG or COS method for our particular problem. Okay. So I think both of the process is very clear to you. Okay. So in this class, what we have learned the basic uh, module of the fuzzy logic controller or fuzzy systems, and after that we have observed what is the necessity of the defuzzification process, and we have also studied the CoG method, center of gravity method, and CoS or center of sum method for the defuzzification process. This centroid method are very popular. Although there are other techniques, those are existing like lambda cut method, weighted method, or the um, MOM method. Okay, but centroid method are the most popular among them. CoG and CoS are widely used for the defuzzification process in the fuzzy logic controller. Okay, so in this class we have learned all these things, and in next class we will study a real life fuzzy logic controller system and observe how it operated. Okay, uh, so these are the few references, those are used to prepare these slides and classes. So if you have any question, please post them. I will be happy to answer all of them. Thank you.